Alright, these notes are from 5.8 of Chapter 5. This is the last section of Chapter 5 that we're going to cover. As title says, solving quadratic equations by factoring. That means you're going to use the factoring that we've already just got through doing, and you're going to use it to solve an equation. A quadratic equation is an equation with a power of 2. Okay? Some of these problems are going to have a power of 3, but we're having common factors and that'll take it down. Technically, what we're doing when we solve a quadratic equation is we're going to have a graph. Every equation has its own kind of graph. A graph of a quadratic equation is something that's going to look like a parabola, and the answers to the problems we're finding will be the 2 dots where this quadratic equation might cross the x-axis. So these 2 points are going to be the answers that you get when you solve a quadratic equation, and you'll have 2 of them. Now, almost every time a parabola will come down and cross the x-axis. Sometimes if the parabola sits down and it just touches the axis and turns around and goes back, it would only have 1 dot here. When you do the problem and work it out, it would actually have 2 answers. They would just be the same number. Now, there are situations where the parabola would sit too high on the graph and it would never come down and touch the axis. And occasionally you have a parabola that's turned upside down and it would never reach high enough to get it. So the ones we're doing today is the problems that are going to give us the 2 spots where the parabola would come through and touch your x-axis. So those are what we call the solutions. Another name for them is the roots of this equation. So we're going to be solving an equation that gets us 2 answers. Now, here's the way that we're going to do it. If I'm multiplying 2 numbers together and the answer comes out to be 0, I know that either the A had to be a 0 or the B had to be a 0. Now, since these are designated by different letters, we will assume that they're not both 0. But that could be possible. But here, what this implies that either this number or this quantity came out to be a 0, and then when multiplied times B still gave us a 0 answer. Or this B value or the B quantity came out to be a 0, and then whatever this is, it will still just multiply out to be 0. So we're going to kind of use that idea as we work through these problems combined with our factoring skills to help us solve a quadratic equation. Now, the equations we're going to work with mostly are x squares and x cubes. Sometimes there's x to the 4ths, and when you start working in the second or third week of, I think it's the 3rd week of college algebra, you're going to be using some of these that have higher powers on them besides squares. Now, this is a little standard step order of what you're going to be doing. First of all, to solve a quadratic equation, you're going to have it in the standard form, and that means you want your x squared term first, and you want it positive, then your middle term with the x to the 1st power, and then any constants that you might have. In other words, you want to get everything on one side and then get it equal to 0 on the other. So the way you start out is you get the binomial or the trinomial that you're working with, and you want to set it equal to 0. Now, the problem, you might have to use a greatest common factor, or you might have to use a difference of squares, or it might be a trinomial. You won't have a grouping problem in these. Then you're going to make some little mini equations after you use your factors, and then you're going to solve it. You're going to solve each one. Now, here's the thing. The highest power, and you're usually going to find it on the leading term, is going to tell you how many answers you need. Okay, how many answers you get will be based on the power. So if I look at my first problem, first of all it says solve. Okay, that means that I'm going to do some factoring on this, but at the end I'm going to have to take my factoring and I'm going to have to solve it to get an x equals answer. When we did factoring on that last worksheet, we just factored and we left the parentheses around our answers, and that's how we stopped. We just basically simplified something. But here we're going to actually work on through the factoring to help us get an answer. So I'm going to look at the problem that I have and determine what category it fits in. Well, it has three terms, so this one would be a trinomial. I have an x squared on the front, and it's set equal to 0, so this problem is already set up ready to go. So you're going to ignore the 0 for the time being, and you're just going to look at your trinomial, and then you're going to see how would I factor that. So I'm going to take the first term and get my x's out of it, and I'm going to look at the minus 64. That means I'm looking for the factors that multiply to get 64 and subtract to give you a 12. You might need your calculator to go through and figure some numbers out. I know that 64 can divide by 8. I know it can divide by 4. I know it can divide by 2. So I would use those numbers and see where can I get my combination that works out to be a 12. I think that would be 16 times 4. So 16 is my bigger number, so I'm going to put a minus on the 16 because my middle sign is negative. And this says the signs have to be different, so plus 4 on the back. If I look at that, that would be negative 16 and positive 4. That gets me the negative 12. Okay, now you're going to bring that equals 0 down. Okay, so now we're going to go back up, and this little property right here is going to work for us. If the A stands for the first parentheses, that would be x minus 16, and we let the B stand for the second parentheses, that's the x plus 4, then either the x minus 16 had to equal to 0, just like we said up here, or the x plus 4 had to equal to 0. Because if I solve this and find out what this number is, and I plug that number back in there, that number would make this all cancel to 0, and 0 times whatever this is still going to be 0. So now all I have to do is add 16 to both sides, so now I get x equals positive 16. So if I stick in positive 16 here, this goes to a 0, and 0 times anything is still 0. Now go over and solve the other one. So if I'm looking at this parentheses, I'm going to take the positive 4 and move it to the other side, so x would become negative 4. So now if I stick negative 4 in, negative 4 and a positive 4 right here would cause this term to give you the 0, which would still give you an answer of 0. So now we have two answers. So on your homework you would write x equals 16 comma negative 4, and that's how you'd write it in your box on your homework. Now what does that say about our little graph up here? Well, it says that the x is going to cross at positive 16, so this would be positive 16 over here, and this would be negative 4, and our parabola would drop down and cross in those two places on that graph. Okay, so here I've got two terms. It's already equal to 0. So I'm looking at these. Those look like squares, and that looks like a minus, so I have a difference of squares. So now I'm going to take my problem and break it apart. And I'm going to have 3x and 3x, which gives me 9x squared. And then I'm going to have a positive 5 and a negative 5, which gives me negative 25. So now I have two separate answers. One's positive and one's negative. And then I just do 3x plus 5. One of them, the one on the left, could have been the 0 number, or 3x minus 5 could have equaled the 0 number. Okay? Solve each one. So I'm gonna subtract 5, and I'll get 3x equals negative 5. Divide by 3. So I get x equal negative 5/3. And over here I'm going to add 5, so I get 3x equals positive 5, and divide by 3, so I get x equals 5/3. Don't put these answers as decimals. Okay, just like that. That's all you need. You can write negative 5/3 comma positive 5/3 when you put it in your box. Okay, they said we should get how many answers? 2, because that's a 2 and an exponent. So if we look over here, our highest exponent is a 3. So this time we're going to get 3 answers for this problem. I have x's, x's, x's. So x becomes my common factor. So I'm going to take it out. And then the problem reduces down to an x squared problem. Now, as you're working these, technically the z equals 0 has to be part of the problem. Don't just write the factors down and forget about the equal 0, because this is part of the problem that you're working, because it's solving an equation. So don't just drop off the 0. Okay, go to this one now. I'm going to keep that little x there sitting out by itself. It's going to get lonely, but we'll come back and worry about it in a minute. So now I need the factors of 15 that add up to 8. And I'll have x and x, and I'll have a 3 and a 5 for the 15, and that does add up to 8. Then I'm going to bring that x down. Now every place that you have a variable is going to be a possible place where you could create something that would make a 0. So anytime you have a variable that sits out here by itself, you just say x could equal to 0. Okay, a variable sitting by itself, 0 is going to be one of your answers. Then over here, I have x plus 5 could have been my 0, or I have x plus 3 could have been my 0. So move this over, you'll get x equal negative 5, and over here you'll get x equal negative 3. Now notice what happens. The answer for x is always the opposite of what's in the parentheses. So if it's positive 5 here, it's going to be negative 5 on your answer. So here you would write x equals 0, comma, negative 5, comma, negative 3, because we had a 3 on our exponent, so we knew we should have 3 answers. Right? The next 3 are a little bit different. This one's got a problem because the 15 is not in the right place, because this needs to be a 0. So I'm going to move the 15, and be careful when you move it, the sign's going to change. So I have 8x squared minus 14x minus 15 equals 0. And now that problem's ready to work. The problem is that 8 is not going to divide off. So when we go back and think about what kind of problem this is, it's going to be a rainbow factor trinomial. So 8 won't divide off. I couldn't even divide a 2 out of it, so I'm going to have to keep the 8. So I'm going to circle the 8, and I'm going to bring it to the 15, and I have x squared minus 14x minus 120 equals 0. Now I'm going to factor this, and I get x and x. I need the factors of 120 that are going to get me a difference. It's going to subtract to be 14. Subtract to be 14. Let's see, 120 would be 2 times 60, 3 times 40, 6 times 20. Will that work? Yes. It has to subtract to get 14. So I'm going to put minus on the 20 and plus on the 6. Big number gets a middle sign. Okay, now what did I circle? Okay, I circled that 8, so I have to come back and finish the problem. Both fractions are going to reduce, so I'm going to end up with x minus, divide both sides by 4. That'd be 5 over 2. And x plus 3 over 4. And I have equal to 0. Now here's where we're a little bit different than if we were factoring. If we were factoring, we would take the 2 and move it in front of the x, and we'd take the 4 and move it in front of the x. But since we're being asked to solve, we don't need to move those over because we can keep fractions here. So solving lets you just keep it like this, so you're going to have x minus 5 halves equals 0, x plus 3/4 equals 0. So now to get x by itself, I'm just move the 5 halves. So I'm going to have x equals 5 halves. And over here, 3/4 is going to move, so it'll become negative. And I'll have x equals negative 3/4. So there's your 2 answers. Now, this one's really you have to be careful that you don't stop too soon and get to 20 and 6 and go, oh, okay, it's just the opposite of those. You got to make sure that that you get in the habit of circling this so you don't forget to come back and work the rest of the problem. Okay, so this is a rainbow problem with a quadratic equation. Here I have two terms and it's not a minus. Okay, here I have two terms and I have squares and a minus. Here I have two terms but I don't have numbers that are squared and I don't have a minus. So all I can do on this one is take out a greatest common factor. It's not a trinomial, so it won't factor like this or like this. So I have to take out a greatest common factor. So I'm going to divide out 2x, and then I have left x plus 5 equals 0. Now I still have an x sitting out here alone, but it's got a 2 in front of it. So it's very similar to this situation right here. If you have a variable in front of parentheses that doesn't have any parentheses, that term is going to give you an answer of 0, because this exponent says I need two answers. So this 2x equals 0 is one answer. If I divide both sides by 2, x is still going to equal 0. And over here I have x plus 5 equals 0. Subtract the 5, so I get x equal negative 5. So here I do have two answers. One of them's 0, one of them's negative 5. That means this parabola, if we go back and look, would have crossed at 0 for one answer and negative 5 for another. So it would have been kind of slid off to the left here. Alright, this last one. By the way, you're going to have one like this on your test. So make sure that you got a star on that and you know how to do that. Alright, 3x cubed minus 10x squared minus 8x. So these aren't in the right order, but there's two things here, but you want to keep this term positive. So don't move the 3, instead move all of this over here. Then you'll have 3x cubed plus 10x squared, oops, plus 8x, right, equals 0. Okay, I can take out an x, so it's going to be similar to this one. I've got a cube. If you've got a cube on the variable, then you've got too many, so you're going to have to take one out. Then you have 3x squared plus 10x plus 8 equals 0. So when I look at what's in the parentheses, I've got a 3 that will not divide off, so it's going to be a rainbow problem. So I'm going to circle the 3, push it to the 8. Then I have x, and then I'd have x squared plus 10x plus 24. I need the factors of 24 that are going to add up to 10. Okay, that would have to be 2 times 12, 3 times 8, 6 times 4. There it is, 6 and 4. So I'm going to have these two as x plus 6 and x plus 4. I rainbowed it with a 3, so I'm going to have to come back under here and put a 3. This x is going to come down and I'll have an x, I'll have an x plus 2, and I'll have an x plus 4/3. And remember again, when you're solving an equation, you can keep the parentheses with a fraction in it. So now you're going to take each one. X would equal 0. X plus 2 has to equal 0, so x equals negative 2. And here x plus 4/3 is going to equal 0, so x would equal negative 4/3. So here we have 3 answers for this problem. So quadratic equations still involve factoring. So make sure that you've done your factoring homework, because the material that we're going to cover in chapter 6 is all about using that factoring again. So this is the material to cover from 5.8 for those of you that were not in class, and this will help you. Thanks. Bye.